Welcome to all of you. Today in this video you will learn about computer languages. Now in computer languages, the fourth topic is fourth generation languages, that is 4GLS. The fourth generation languages were developed to get closer to human language in terms of thinking and concept than any previous generation languages. It is independent of operating system. Some examples of 4GLs are SQL, Focus, Metafont, PostScript, Wave, Gauss, Python, and so on. Now what are the features of fourth generation languages? It is more programmer friendly and versatile. It requires minimum efforts from the user. It enhances programming efficiency with the uses of English like words and phrases, icons, graphics, interfaces, and symbolic representation. It possesses high speed of execution as compared to the languages of previous generations. The fourth generation languages are designed to reduce the overall time, effort, and cost that is incurred during the development of any software. Next topic is fifth generation languages, that is 5GLS. Fifth generation languages are used in artificial intelligence research. Its primary goal is to eliminate the need of implementing an algorithm to solve a problem. It means that unlike the earlier generations of programming languages, which were designed to build specific programs, the fifth generation languages are designed to make the computer solve a given problem on its own without any interference of the programmer. Its ultimate aim is to make computers behave, think, and react as human beings. Once a programmer dictates how the solution should appear by logically specifying constraints and conditions, the computer is then free to search for a suitable solution. A considerable research has gone into the development of 5GLS in the 1980s and 1990s. Fifth generation programming languages are still in the development phase. It is believed that the fifth generation languages lead the future. Some examples of 5GLS are Prolog, OPS5, and Mercury. Now the last topic is translators. A translator or language processor converts the instructions into a machine language to make it a computer understandable language. And in this figure we can see different types of translators used by a computer. So in these types of translators there are assembler, compiler, and interpreter. First is assembler. An assembler translates the assembly language programs into machine language programs. So see in this figure how assembler converts the program which can be understood by the processor. So in this first assembly language programs takes the input and assemblers convert it and then output goes to the machine language program. Okay. Second is compiler. A compiler is a language translator program which converts a high-level language program into machine language. As shown in figure, it translates the entire program into machine language that once, as soon as all syntax errors are removed. It takes less time to compile machine code. So according to the figure, first high-level language programs takes the input and it's converted by a compiler, then output to the machine language program. Last is interpreter. Unlike a compiler, an interpreter translates a program line by line. It takes up one statement of high-level language at a time, translates it, and then executes the instructions. Interpreter repeats the same procedure until the last statement is translated into machine language. As you can see in this figure, the high-level language program takes the input, then interpreter do the conversion and then output as a machine language program. So if there are any syntax error in the source program, they are brought to attention of programmer as soon as a program statement is interpreted. Thus it makes finding and correcting errors easier and quicker. Thank you.